This video is about secant, cosecant, and cotangent. This is AP Precalculus, topic 3.11. If you appreciate the content, please give it a like. Number 1. Let f of x equal the cosecant of 2x. Which of the following is a vertical asymptote on the graph of f? I'm writing this statement in a thought bubble because this is not something you need to write down, but you should be thinking the cosecant of 2x is equal to 1 over the sine of 2x. Therefore, cosecant will have a vertical asymptote wherever the denominator, the sine of 2x, is equal to 0. In other words, we can find the vertical asymptotes by setting the sine of 2x equal to 0 and solving. First, we solve for 2x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So 2x is equal to 0 and pi, among other solutions. We can get x by itself by dividing both sides by 2. 0 divided by 2 is 0, and pi divided by 2 is pi over 2. Let's look for 0 or pi over 2 among the answer choices. And there it is, x equals pi over 2. So the answer is C. Number 2. In the xy plane, the graph of which of the following functions has a vertical asymptote at x equals pi? Consider option A. The secant of x is equal to 1 over the cosine of x. So secant will have a vertical asymptote wherever the denominator, cosine x, is equal to 0. So we can find vertical asymptotes by setting cosine x equal to 0 and solving. We can solve this equation by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So x is equal to pi over 2 or 3 pi over 2. We were looking for x equals pi, so A is not the answer. For option B, we should be thinking secant is equal to 1 over cosine. So secant will have a vertical asymptote wherever the denominator cosine is equal to 0. So we can find the vertical asymptotes by setting the cosine of x minus pi over 2 equal to 0. First, we solve for x minus pi over 2 by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So x minus pi over 2 will equal pi over 2 and 3 pi over 2. These are the first two solutions. We can solve for x by adding pi over 2 to both sides. 1 pi over 2 plus 1 pi over 2 is 2 pi over 2, which is pi. 3 pi over 2 plus 1 pi over 2 is 4 pi over 2, or 2 pi. We were looking for x equals pi, and we found it. So the answer is B. Number 3. In the xy plane, the graph of which of the following functions has a vertical asymptote at x equals 1? For option A, we think cosecant x is equal to 1 over sine x. So cosecant x will have a vertical asymptote wherever sine x is equal to 0. You can solve this equation by asking yourself the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So x is equal to 0 or pi. We were looking for x equals 1, so A is not the answer. For option B, you should be thinking cosecant of pi x is equal to 1 over the sine of pi x. This function will have a vertical asymptote wherever the denominator, sine of pi x, is equal to 0. So we can find the vertical asymptotes by setting the sine of pi x equal to 0. First, we solve for pi x by asking ourselves the sign of what is equal to 0. Sign is the y value on the unit circle, and y values are equal to 0 here and here. So pi x will equal 0 or pi. We can get x by itself by dividing both sides by pi. 0 divided by pi is still 0, and pi divided by pi is 1. We were looking for x equals 1, and we found it. So the answer is B. Number 4. Let g of x equal cotangent of pi x over 2. Which of the following is a vertical asymptote on the graph of g? You should be thinking cotangent is equal to cosine divided by sine. So the cotangent of pi x over 2 will have a vertical asymptote wherever the denominator, the sine of pi x over 2, is equal to 0. So we can find the vertical asymptotes by setting the sine of pi x over 2 equal to 0. First, we solve for pi x over 2 by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So pi x over 2 is equal to 0 or pi, among other solutions. We need to get x by itself. Let's start by multiplying both sides by 2. If we multiply by 2 on the left, the 2 cancels out and we are left with pi x. 0 times 2 is 0, and pi times 2 is 2 pi. We can get x by itself by dividing both sides by pi. 0 divided by pi is still 0, but when you divide 2 pi by pi, the pi's cancel out and you get 2. So let's look for 0 or 2 among the answer choices. Well, there's x equals 2 right there, so the answer is D. Number 5. Let h of x equal 2 minus 5 cosecant of 4x. Which of the following statements about the graph of h is correct? All of the answer choices mention an equation which gives the infinitely many vertical asymptotes of h of x. Vertical dilations and vertical translations will not affect the position of vertical asymptotes, so we can ignore the 2 and the negative 5. We should be thinking the cosecant of 4x is equal to 1 over the sine of 4x. So the function h of x will have vertical asymptotes wherever the denominator, sine of 4x, is equal to 0. So we can find all of the vertical asymptotes by setting the sine of 4x equal to 0 and solving for the infinitely many solutions. First, we solve for 4x by asking ourselves the sine of what is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So 4x will equal 0 or pi, and then there are infinitely many more solutions as I go around the unit circle. However, this time I don't want a list, so I'm going to start with my first solution, which is at 0, and then realize that I can get to my next solution by adding pi. In fact, if I add pi again, it'll take me to another solution. As I keep going around the unit circle, every time I add pi, it takes me to the next solution. So I can find all of the infinitely many solutions by adding multiples of pi. In other words, by adding pi k, where k is any integer. The 0 is not really doing anything, so I'm going to erase it. We can get x by itself by dividing both sides by 4. That gives x is equal to pi over 4 k, where k is any integer. This does not exactly match any of the answer choices. However, I feel I can eliminate options C and D. Only options A and B have the pi over 4k added on. In fact, I'm pretty sure the answer is simply going to be B, because we are talking about the asymptotes are multiples of pi over 4. And adding an extra pi over 4 to an infinite list of multiples of pi over 4 is not really changing the set. It's the same set of numbers. Let me prove that to you. First, consider the multiples of pi over 4. When k is 0, that's 0 times pi over 4, which is 0. When k is 1, that's 1 times pi over 4, which is pi over 4. When k is 2, that's 2 pi over 4, which would reduce, but I'm going to just leave it as 2 pi over 4 to make the math easier. When k is negative 1, that's negative pi over 4. And when k is negative 2, that's negative 2 pi over 4. Now consider the values of pi over 4 plus pi over 4k. These values will be the same as the values above plus an extra pi over 4. So, for example, 0 plus an extra pi over 4 would be pi over 4. Pi over 4 plus an extra pi over 4 would be 2 pi over 4. Negative pi over 4 plus the extra pi over 4 would be 0. Negative 2 pi over 4 plus the extra pi over 4 would be negative 1 pi over 4. Notice how the values of pi over 4 plus pi over 4k are the same as the values of pi over 4k, just shifted over 1. Since both of these sets go forever in both directions, these sets are equivalent. So in general, if you have a set that's made up of all of the multiples of something, adding an extra multiple does not actually change the set, so you can ignore it. And the answer is B. Here's a quick side lesson to emphasize what I just said about having a set of multiples of something and then adding an extra one. For example, if I have pi k, where k is any integer, and then I add an extra pi, that does not change the set. This will be equivalent to simply pi k. Multiples of pi over 2 plus an extra pi over 2 is the same as just multiples of pi over 2. One more time, multiples of pi over 8 plus pi over 8 is equivalent to multiples of pi over 8. Actually, let me wrap up this side lesson by going back to the first example. If I have multiples of pi, and then I add not just 1 pi, but 2 pi, or 3 pi, or 4 pi, that is still equivalent to simply multiples of pi. Number 6, let h of x equal 2 times the cosecant of 4x. Which of the following gives the range of h? In a previous video, we learned that the range of the parent function cosecant x goes from negative infinity to negative 1, union 1 to infinity. Focus on the key y values of 1 and negative 1. Let's see how the transformations that create h of x affect these key y values. The only transformations that will affect y values are the ones that are outside the trig function, in this case the vertical dilation by a factor of 2. So the new y values will be 2y, 2 times the original y values. So the new y values will be 2 and negative 2. The original range went from negative infinity to negative 1, union 1 to infinity. The new range will go from negative infinity to negative 2, union 2 to infinity. So the answer is B. Number 7, let k of x equal 7 minus 3 times the secant of 2x. Which of the following gives the range of k? We have memorized that the range of secant x goes from negative infinity to negative 1, union 1 to infinity. Pay attention to the key y values of negative 1 and positive 1. Let's see how the transformations that create k of x affect these key y values. The only transformations that affect y values are the ones that occur outside the trig function. In this case, the vertical dilation by a factor of 3, the reflection over the x-axis, and the vertical translation by 7. In other words, we can get the new y values by doing 7 minus 3y. So let's see, if y was 1, then 3 times 1 is 3, and 7 minus 3 is 4. If y is negative 1, we have negative 3 times negative 1, which is positive 3, and 7 plus 3 is 10. The original range went from negative infinity to negative 1, union 1 to infinity. The new range will go from negative infinity to 4, union 4 to infinity. I had to sort of mentally flip it around from least to greatest. But again, the range will go from negative infinity to 4, union 10 to infinity. So the answer is C. Number 8. Let f of x equal 5 plus radical 2 secant x and g of x equals 7. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of f and g between 0 and 2 pi? We can find the x-coordinates of the intersection points by setting function f equal to function g and solving. First, we subtract 5 from both sides. That leaves radical 2 secant x is equal to 2. Next, we divide both sides by radical 2. That will leave the secant of x is equal to 2 over radical 2. Secant is the reciprocal of cosine. So if we take the reciprocal of both sides of this equation, we have the cosine of x is equal to radical 2 over 2. If you have not yet memorized these 9 trig values, pause the video and memorize this chart right now. We can find the reference angle by asking ourselves the cosine of what is equal to radical 2 over 2. We have memorized that the cosine of pi over 4 is radical 2 over 2, so the reference angle is pi over 4. The reference angle is the angle between the terminal side and the x-axis. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 4. There's one in every quadrant. However, in this case, we want the cosine to be positive, and cosine is the x value on the unit circle. X values are only positive on the right-hand side in quadrants 1 and 4, so we will only consider solutions in these 2 quadrants. In the first quadrant, the angle with the reference angle of pi over 4 is pi over 4 itself. But what about the fourth quadrant? Well, pi is right here, and looking at the reference angle, we will think of it as 4 pi over 4. Doubling this, we can think of 2 pi as 8 pi over 4. That means the angle in the fourth quadrant that has a reference angle of pi over 4 is pi over 4 less than 8 pi over 4. That's 7 pi over 4. So these are the x-coordinates of the 2 intersection points. Number 9. Let h of x equal 2 minus radical 3 cotangent x, and k of x equals 3. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of h and k between 0 and 2 pi? Let's set h of x equal to k of x and solve. First, we subtract 2 from both sides. That leaves negative radical 3 cotangent x is equal to 1. We isolate cotangent x by dividing both sides by negative radical 3. That will leave the cotangent of x is equal to negative 1 over radical 3. Cotangent is the reciprocal of tangent. So if we take the reciprocal of both sides of this equation, we have the tangent of x is equal to negative radical 3. The reciprocal of 1 over radical 3 is radical 3 over 1, which is simply radical 3. We can determine the reference angle by ignoring the negative sign and asking ourselves the tangent of what is equal to radical 3. We have memorized that the tangent of pi over 3 is radical 3. So pi over 3 is the reference angle. We have learned that the tangent of an angle is the slope of the terminal side. In this case, we want the tangent, and thus the slope, to be negative. So we will only consider quadrants where the terminal side would have a negative or a downhill slope. That's going to be quadrants 2 and quadrants 3. Notice how the terminal side has a negative downhill slope in these two quadrants. Remember that these two angles have a reference angle of pi over 3. Pi is right here. Looking at the reference angle, we will think of it as 3 pi over 3. So this angle in quadrant 2 with a reference angle of pi over 3 is pi over 3 less than 3 pi over 3. That's 2 pi over 3. Doubling this, we can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant is pi over 3 less than 6 pi over 3. That's 5 pi over 3. These are the x-coordinates of the two intersection points. Number 10. Let m of x equal 1 plus 2 cosecant squared x and p of x equals 9. In the xy plane, what are the x-coordinates of the points of intersection of the graphs of m and p between 0 and 2 pi? Let's set m of x equal to p of x and solve. First, we subtract 1 from both sides. This leaves 2 cosecant squared x is equal to 8. Next, we divide both sides by 2. This leaves cosecant squared x is equal to 4. We can unsquare the cosecant by taking the square root of both sides of the equation. Be careful, when you take the square root of both sides of an equation, the solution will be plus or minus. So we will have plus or minus 2. Obviously, the square root of 4 is 2. Cosecant is the reciprocal of the sine function. So if we take the reciprocal of both sides of this equation, we get the sine of x is equal to plus or minus 1/2. We can determine the reference angle by ignoring the plus or minus and asking ourselves the sine of what is equal to 1/2. We have memorized that the sine of pi over 6 is equal to 1/2. So the reference angle is pi over 6. Between 0 and 2 pi, there are 4 angles with a reference angle of pi over 6. There's one in every quadrant. These angles are special because the sine of any of these angles will give us some kind of a 1/2. It's just that 2 of them will give us positive 1/2 and 2 of them will give us negative 1/2. In this case, we are looking for the values of x that will cause sine to be positive or negative 1/2. So all 4 of these angles are solutions. In the first quadrant, the angle with a reference angle of pi over 6 is pi over 6 itself. Pi is right here. Looking at the reference angle, let's think of it as 6 pi over 6. The angle in the second quadrant with a reference angle of pi over 6 is pi over 6 less than 6 pi over 6. That's 5 pi over 6. In the third quadrant, this angle is pi over 6 more than 6 pi over 6. That's 7 pi over 6. Doubling this, we can think of 2 pi as 12 pi over 6. And this angle in the fourth quadrant with a reference angle of pi over 6 is pi over 6 less than 12 pi over 6. That is 11 pi over 6. These are the x-coordinates of the 4 intersection points. Hey guys, don't forget to like and subscribe, but But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.